Friends, in today's class we are going to discuss about the lenses. Lenses are actually the part of the transparent material, and they have certain very special characteristics that they can either converge or diverge the light rays which incident on them. On the basis of whether the lens diverge or converge, and also on the basis of their shapes, there are two types of lenses. One is called convex lens and another is called concave lens. Now, as far as the convex lens is concerned, in the convex lens you can see here that this type of lens in which the lens which is thicker in the middle and thinner at the extreme points, this type of lens is called convex lens. Now you can see, if this is the first surface, you can see that this actually in the lens there are two spherical surfaces. This is the first surface and this is the second surface. When you think about the first surface, you can see that this first surface is actually the part of a bigger sphere. So this first surface is part of this bigger sphere. Okay, was part of this bigger sphere, and this second surface can be considered as the part of this another sphere. Okay, and these 2 points are the center of curvatures of the two spheres of this lens. Now, this type of lens is convex lens. This type of lens is concave lens, in which the lens is thinner at the center and it is thicker at the edges. Okay, now this is also actually the part of the sphere only. You can see that both of them are actually the part of the sphere. Like this you can complete it. So here we have two center of curvatures. Okay, and this type of lens is known as the concave lens. This type of lens is known as the concave lens. So this is the concave lens. Okay, convex lens is also known as the converging lens. It is also known as the converging lens because it converges the light rays which incident over it. Concave lens is also known as diverging lens because it diverges the light rays which incident over it. That's why it is also known as diverging lens. Okay. Now there are some very important definitions related to concave and convex lens that we are going to see. This particular line is called the aperture or the diameter of the lens. Now, as I told you that there are two center of curvatures, so if you join these two center of curvatures of the lens, then the line joining the two center of curvatures of the lens will give you this line is called the principal axis. So this line which I have drawn just now is called the principal axis. This is the principal axis. Principal axis. This is called the aperture. This is called the aperture of the lens. Now the point where these two meet, the aperture and the principal axis, this is called optical center. This is called optical center of the lens. Now optical center of the lens, it also has one very important characteristic, and what that characteristic is, do remember that whenever a light passes through the lens and it is passing through the optical center, then what happens that the light, it remains undeviated. When it passes through the optical center, then it remains undeviated. So equal refraction, equal but opposite refraction takes place when light passes from air to this surface and from this surface to air, and that's why the light ray remains undeviated. So actually the refraction is taking place at this surface and at this surface, but the refraction is taking place in such a manner that it is equal in magnitude but opposite in direction. Okay, so optical center is a point on the principal axis of the lens such that the light ray which passes through this point remains undeviated. Now there are some more definitions which we have to see. Okay, here also you can see that here we have the optical center. Okay, this is the principal axis. This is the principal axis, and here we have the optical center. So if light ray passes through it, it remains undeviated like this. Okay. Now some more definitions we will try to understand. For that I am removing all these things, and now we will be discussing in detail about the convex and the concave lenses. Okay. First definition of focus. Suppose that this is the convex lens, and if the light ray is incident parallel to the principal axis of the convex lens like this. If the light ray is incident parallel to the principal axis of the convex lens, then after refraction from the lens, they actually passes through one point, and this point is called the focus of the lens. So light rays which incident parallel to the principal axis of the lens after reflection passes through a point on the principal axis, and this point is said to be the focus of the lens. Now, do remember that as we studied it in case of mirrors, that all the distances are measured from the pole. Okay, so there is one very important sign convention. There is one very important sign convention here. And what that sign convention is, the sign convention is that the all distances are measured from optical center. The first sign convention is that all distances are measured from optical center. This is the first sign convention. Second sign convention is that all the distances which are measured in the direction of the incident light rays, that is, all the distances which are measured towards the right of the pole, right of the optical center, are taken positive, and all the distances which are measured in the opposite direction of the incident light ray, that is in the opposite direction, that is the left hand side of the optical center, then these distances are taken negative. Next sign convention is that the heights which are measured up to the principal axis are taken positive, and down to the principal axis are taken negative. Okay, so these three sign conventions, they are almost same as we studied in concave mirror, because it has to be used here, so that's why I discussed these sign conventions, so that we don't need to discuss it afterwards. Now, as I told you that all distances we have to measure from optical center. So the distance between the optical center and the focus, this is called focal length, denoted by small f. So small f is called focal length. Do remember that in case of convex lens, because you have to go towards the right of the optical center, that's why the focal length is always positive. In case of convex lens, the focal length is always positive. Okay. Now if you see the concave lens, in the concave lens, if the light rays, this is the principal axis, if light rays incident parallel to the principal axis, then after refraction, light rays appear to come from a point on the principal axis. Light rays appear to come from a point on the principal axis like this. So this particular point from which light rays appear to come, this is called the focus of the convex lens. Okay. Actually, convex and concave lenses, they possess two focus, because there are two curved, two spherical surfaces. That's why they possess two focus. I will come on to that point also, but this point is the focus point. This is the first focus. Okay, and this is the optical center. So that's a distance between the optical center and the focus. This distance is said to be the focal length. Okay, now you can see very easily here that the focal length of the concave lens, this has to be negative. This is negative. Focal length of a concave lens is negative, because in order to measure it, you have to go towards the left hand side, or you say in the opposite direction of the incident light. So that's why this is taken negative, okay, by the sign convention. Okay, so focal length of convex lens is positive, focal length of concave lens is negative. This is what the very basic definition related to convex and concave lenses. Okay, one more very important thing we will be discussing, it is that as we know that convex lens it converges the light rays and concave lens it diverges the light rays. So why does it so? Why the convex lens converges the light rays? I would like to discuss it with you. Try to understand that if we are talking in context of convex lens, I am making a big diagram so that you can understand it. Okay, because you have to understand what is happening exactly to the light rays. Okay, so this is the principal axis. Okay, and for the first surface, the radius of curvature must be lying somewhere because it is a big surface, so that's why the radius of curvature must be lying somewhere here. And similarly, for the second surface, the radius of curvature must be lying somewhere here. Okay. Now you see that if a light ray incident like this, parallel to the principal axis like this. When the light ray incident parallel to the principal axis like this, so what happens that here we have air and here we have glass and again we have air. Correct? So when light passes from air to glass, at this point of incidence, what happens that light ray will either, because it is traveling from rarer to denser medium, so that's why either when it travels from rarer to denser medium, it bends towards the normal. So we have to draw the position of the normal at this point. And do remember that this is the first surface, so that's why this is the center of curvature of it. Okay, and because of that, what will happen that the light ray will bend towards the normal. For that you have to draw the normal. So if I draw the normal at this point of incidence, I have to join this point to the point C1 on the principal axis. So if I do this, this is the normal. Okay, now what will happen that the light ray will bend towards the normal. If it bends towards the normal, it goes like this. It bends a bit towards the normal, like this it bends. Now at this point what happens that light passes from glass to air. If it passes from glass to air, definitely it will bend away from the normal. Now for that, at this point we have to draw the normal. So at this point, if we have to draw the normal, what we will do, we will be joining this point, say C2 to this. Okay, so if I join this, we will be getting like this, the center of curvature. So this is the normal. You know the line joining the center of curvature to any point on the circumference of the lens will give you the position of the normal. So this is the normal. Now what happens when the light passes from denser to rarer medium, it bends away from the normal. So it will bend away from the normal. So it goes like this now. Okay, so overall effect, if you see, you will see that the overall effect is like this, that the light ray which is incident parallel to principal axis, it is bending towards the principal axis. Okay, so if in short we say, if this is the convex lens and the light ray is incident like this, so they bend towards the principal axis, and because they bend towards the principal axis, so that's why the overall effect is that they converge the light rays. They converge the light rays. Okay, and that's why convex lens is a converging lens. I hope it is clear to you. Similarly, we can prove it for the concave lens, that the concave lens is a diverging lens. Same thing I am doing a bit fast. I will not explain it. I will just draw it. Okay, so if I am doing this, so you see here that we have a big concave lens here. If we have a big concave lens, which I am drawing here, so here is the concave lens. This is the concave lens. Okay, and now what we have to do, we have to complete this sphere. So this is the part of a huge sphere like this. It is being drawn. Okay, and this is the part of this second sphere which is there. Okay, now you know this, that this is actually the center. This is the optical center, and here we have the center of curvature. So if I join these, this is what we got now. Okay, so this is the first, you see this is the first surface now, and because this is the first surface, so that's why its center of curvature will be lying here. This is C1, and its center of curvature will be lying here, so this is C2. Okay, now if we take a light ray which incident parallel to the principal axis, suppose that this is the light ray which incident parallel to the principal axis. Now what will happen? What will happen that at this point light passes from air to glass. Here we have the glass, and here we have the air from which it is passing. So when light passes from air to glass, what happens to it? That it bends towards the normal. So we have to draw the normal here. Okay, so if we have to draw the normal, we will be joining this C1 to this point. So if we join this point, then this is the center of, this is the radius of curvature. Okay, now light ray when passes from rarer to denser medium, it bends towards the normal. So it bends towards the normal, so that's why the light ray, this light ray will bend towards the normal a bit. So it goes like this here, it goes like this. Now at this point what will happen, that light ray has to travel from denser to rarer medium. If it has to travel from denser to rarer medium, then again we have to draw the position of the normal at this point, and because this is the second surface, the normal position would be from this. So I'll be drawing it like this. Like this. So this is the normal for this second surface, and now the light ray will pass from denser to rarer medium, so that's why it has to bend away from the normal, and because it has to bend away from the normal, you can see that the light ray will follow a path like this away from the normal. And if you see the overall effect of the lens when it passes through the when the light ray passes through the lens, the overall effect is that the light ray which is incident parallel to the principal axis, it bends away from the normal. So if I draw other light rays also, if I draw it like this, so you can see that the overall effect of the concave lens is that it diverges the light rays. Okay, so this is how it diverges the light rays. Okay, that's why the concave lens is called the diverging lens. I hope it is clear to you.